Do you want to learn, understand, enjoy, and master and apply the concepts of basic applied mathematics? Are the first two questions I would like to ask you. If the answer is yes, then you are in the right place for you to achieve that, or for you to get the answer of that questions which I asked you at the beginning of this session. How are you, everybody who is watching these programs? I would like to take this opportunity to welcome our online, national and international students who would like to take this advantage of learning basic applied mathematics in order to apply in different advanced subjects. So my name is Olenjolai, Moko Tayai Losingo, simply call me Olenjolai. I thank God by His own grace, He has called me to be a national and international teacher who has a responsibility to teach you basic applied mathematics for advanced secondary education in national level and international level. So that's by own grace, by the grace of God. So I'll be here in order to teach you what you have to cover in advanced secondary school. So I would like to take this opportunity to welcome you firstly into one of our online school that called Tanzania Online Advanced Secondary School in square bracket OLENJOLAIM. Simultaneously, I would like to take this opportunity to welcome you into one of our official YouTube channel that called the Tanzania Online A-Level Secondary School in square bracket OLENJOLAIM. So what are we doing, or what are the visions of TOASO in abbreviation? Okay. That's the second thing that I would like to just to remind you, if you've heard for in previous sessions, but I would like to also to declare it to our new online advanced secondary students. So we have an assignment that has been given by God to teach you on how you have to understand, master, enjoy, and extract knowledge, wisdom, and understanding from the classroom instructions in basic applied mathematics, advanced physics, advanced chemistry, advanced mathematics for Form 5 and Form 6, and combine the extractions or the thing that mean that the contents that will teach you to extract it with the knowledge, understanding, and wisdom that you are going to teach our students to extract it from the Word of God written in the Holy Bible in order to solve real-life problems. So we are here in order to teach you how you have to think outside of the classroom in order to solve real-life problems. So that's the point that you have to do. What problem am I solving? Am I solving your problem? Am I solving your students, your child's problems? Am I solving your son's problem? Am I solving your daughter's problem? Am I solving your own problem? That's the question that is going on in your mind if this is the first time to meet me. Actually, myself, I am a Tanzanian, and I'm doing these programs for the Tanzanians, and this is our national flag. I would like to welcome all the international viewers into our beautiful country. I have an assignment, or I did my research when I have been teaching. When I was doing my advanced secondary educations, I did advanced mathematics, advanced pure mathematics in my high school education. But I was studying also with some of my colleagues who were doing the PCB. I mean that advanced physics, advanced chemistry, advanced biology, who have to learn about basic applied mathematics. Really, they have been encountering so many challenges on learning, understanding, enjoying, and mastering different concepts in basic applied mathematics. So again, I realized the same problem existing to a large number of advanced secondary students who are studying basic applied mathematics as one of the subsidiary subjects. So I spend my time on teaching some of the students in this entire country. For more than 100 students, I taught them basic applied mathematics at most technical. But right now I said, okay, let me enlarge the tent of my teaching to teach different students in different schools, in different regions, in different cities of Tanzania, in Africa, America, Asia, Europe, and Australia. So that is the problem. So I'll be using different teaching aids. I'll be using different teaching techniques. I'll be using different teaching approach, teaching methodology. I'll be using different and simple teaching style to make sure that every advanced secondary students who is studying this six combination, either this six combination, understand it means that understand, enjoy, and apply the concepts that have to be covered in basic applied mathematics. So here I am just to share. Remember that Olenjolai does not know everything about basic applied mathematics. I thank God by His own grace, I'm always learning new concepts. And also, what I have, just I know small portions of basic applied mathematics for the Form 5. And I have a responsibility to teach these contents to undergraduate, to high school students. I have a responsibility to teach them what I know. So remember, I don't know everything about basic applied mathematics, but I have a responsibility to teach what I know about basic applied mathematics. So don't boast yourself, don't ignore your classroom teachers, take advantage of them, right? So I would like to spend also a few minutes to welcome you into one of our online, just into the few steps that you have to follow for you to register yourself into TOASO. TOASO is the abbreviations of Tanzania Online Advanced Secondary School in square bracket Olenjolai. The first thing, if you don't have an email, then we ask you to create or open a new email, right? If you don't have an email. If you have, remember the password and username. How do you open the new email? For high school students in Tanzania, I know that most of them, they don't have an email. So you have just to go into Google or Yahoo, just see, and then, or into Google search engine, and then how can you open a new email address, whether a Gmail or a Yahoo. The second step, we ask you to sign in YouTube by using the email you have created, or your past email. Then the third step, we ask you to search TOASO in YouTube. And once you search it, you have to write to copy and paste this name, Tanzania Online A-Level Seki School in square bracket Olenjolai. Once you search it, you'll see these round buttons with the Tanzania national flag. Okay, once you search it, you'll see this one. So we ask you to click the round button. Once you click the round buttons, then you'll have a trailer video, and also you have some other videos and some other categories. But at the top, you'll see horizontal bar that returns home, videos, playlist, community, channel, and about. I'll come back here when I will reach into the sixth step. So how can you register yourself permanently? That's the good questions that I would like to spend a minute to answer. So at the just check your video. Somewhere else you'll find a button written subscribe. So we ask you that to click subscribe. Once you click it, it will change. The text will change from subscribe into subscribed. And at the same time, you'll see an icon of the bell beside it. So we ask you to click these icons of the bell, and you see 3 options. We ask you to choose just the options of all. So here, for you to register yourself, you have just to follow 3 steps. Now, the first step, click the button written subscribe. The second step, click the icons of the bell. The third step, choose the options of all, and then at the bottoms of your mobile phone or at the bottoms of your computer, you'll see that a text or a message from the YouTube community that you will receive all the notifications. Why should you subscribe? Because we have a vision to record and publish more than 500 videos of advanced educations in advanced mathematics, advanced physics, advanced chemistry, and advanced basic applied mathematics for the Form 5 and Form 6, 8 subjects that we are teaching ourselves. So that's why that we ask you that register. Every day we have a responsibility to add at least 1 video. So this is session 4. In case that you want to join us in session 6, in session 5 and 6 and 7 and 8 and 9, then we ask you that you to subscribe, then you'll get notifications. And also we ask you, in order for you to be an active student, we ask you to visit or to use the internet consistently to learn these contents, because you cannot access them offline. The 6th step, so that's, you have already registered yourself permanently. The 6th step, we ask you to click playlist and then find the playlist which is written algebra, maybe in square bracket. I think that because you have algebra in pure, so this will be algebra in math, in basic applied mathematics. So search this playlist, you'll find the collections of all the sessions about algebra. Again, to share this video link to other students or parents. If your parents are watching these programs, or your guardians, or a sponsor, you're welcome via the social media, because we know that you love our contents. Then click the icon share below of this video, and you can share the video link to other students, other parents, other guardians, other sponsors, through Facebook, through WhatsApp, through Telegram, through Instagram, through Twitter, through TikTok, through email. So you're welcome to us. So another thing, the registration, there's no any registration fee, and it's a one lifetime registration. We want to give you a guarantee that we'll be trying our level best to have every slow learner, every intermediate learner, and every faster learner students to master the subject of basic applied mathematics. So in case you feel from your heart that you want to offer your feeling thanksgiving to God through this program, don't hesitate yourself to do it through the telephone number 0759745331. And your feeling thanksgiving will be received with the hands of thanks, and will be used specifically to pay for the running cost to produce more than 500 videos at appointed time, according to the time which has been set by the Alpha and Omega, my Father who is in heaven, the God of Abraham, Isaac, and Jacob. So we are in departments of advanced mathematics. The subject of the day is basic applied mathematics, and these contents are for the pre-form 5, for the form 5, for the QT, for the reciters of the four who are studying the following combination, because this is the subsidiary subject: PCB, CBG, ECA, CBA, HGE, CBN, and this is chapter 3, we call it algebra. And we are in second subtopic. We are done with the first subtopic that was called the simultaneous equation. And this second subtopic is called finite and infinite series. This is session 4, intro of finite and infinite series. So if you have finished all of those procedures, then welcome now to enjoy, because we are starting the new subtopic. So there's no need for me to do the quick review, because the previous subtopic was covering some other stuff, and today's subtopic is covering other stuff. So in case you want to access session 00, the general introductions of basic applied mathematics from 5 and from 6, session 1, session 2, session 3, then just visit into our online into our Tanzania online A-level circuit school, use bracket Olenjolai M, and then you access our content. So let us go into the today's session. I will give you one of the important announcements later on when we'll be continuing with this session. So are you ready to enjoy the beauty of basic applied mathematics? Don't hesitate yourself, don't be disappointed if you've given up to enjoy the beauty of basic applied mathematics. Try to also, and then you have something to tell your colleagues. So today I'm teaching you about introduction. I want to lay the foundation, introductions of finite and the infinite series. Okay, so this is not the first time for you to hear about finite and infinite series. We taught you the fifth topic of basic mathematics form 3, and the topic called the sequence and series. So before we go into the series, sometimes many students are used to confuse series and sequence. So let us start with the sequence first of all. So stay with me, sequence of numbers. Okay, sequence. So the fundamental question is, what is sequence? What is sequence? And how we can differentiate sequence from series. So simply we say that sequence in mathematics, sequence is an ordered set of numbers, that follow a certain rule. Follow a certain rule of numbers. Okay, so mean that a sequence is an ordered set. So this is an ordered set of numbers that follows a certain what? A certain rule of numbers, and each term is separated by comma. Very important. Each term is separated by comma. So we have types of ordered sequence. So you have types of sequence. So you say that in basic applied mathematics, there are two types of of sequence. Just to remind you, because some of the students I know they are reading ECA, doing business, so they didn't have good foundations of basic mathematics. So in math, there are two types of sequences. These are, the first one is called the finite sequence, and also the second one we call the infinite sequence. Finite sequence and infinite sequence. So these contents are for the pre-form 5 who are expecting to study either of those 6 combinations. You have to start subsidiary mathematics as basic applied mathematics. So I say that finite series, or finite sequence. So just to explain in short, finite sequence is a set of ordered pair, is a set of numbers, a set of numbers with last term or limited number. We thought limited number of terms. Example of finite sequence is 1, 2, 3, 4, 5, 6, 7, 8. This is the first example. Second example, you can have a set of even numbers, 2, 4, then we have 6, we have 8, we have 10, we have dash dash dash, then we have 20. So this is finite sequence. And we can have a finite sequence of fraction 1 over 2, 1 over 4, 1 over 8, 1 over 16, and possibly up to 1 over 32, 1 over 64, no, 1 over 128. It can be either a set of ordered pair of fractions or numbers. Number 2, infinite sequence. Infinite sequence. So in finite sequence, we say that set of orderly numbers without limited number of terms. Without limited number of terms. So it means that this is without the last term. So you can pause the video and then list those 7 steps for you to take advantage of this stuff. So pause the video and then list these 7 steps for you to access our content easily. Thank you for following steps and being an active and permanent student of TOPASO. Okay. So examples of infinite sequence is this: 1, 2, 3, 4, 5, 6, 7, and then continues to infinity. Second example can be a set of odd numbers: 1, 3, 5, 7, 9, 11, then it continues without the boundary. The example of the infinite sequence can be a sequence of fraction: 1/2, 1/4, 1/8, then continues to infinity. So this is a fundamental concepts of sequence, and series. So remember that sequence is not series, and series is not sequence. So in order for you to distinguish, this was 1. So let me teach you and remind you about series. Okay, remind you about series. So question: what is series? What is series? So we say that series is a set of what? Is a set of numbers. Is a set of numbers. Is a summation of set of numbers. The summation of set of numbers is a summation of set of numbers that follow a certain rule. It's the rule of numbers. So simply, series is a summation of the set of numbers that follow a certain rule of numbers. That means of series. And then, so for this case, means series is not sequence. So you say types of what? Types of series. What are the types of series? So you say that in BAM there are two types of series, which are, first one is called finite series, and the second one is called infinite series. So remember, the head, subtitle of this session, or session 4, is Introductions of Infinite and Finite Series. So after reminding you about sequence, which we find that the consecutive terms are separated by commas, then let us come into the finite and infinite series. So we say this is 2.1 finite series. Finite series. So what is finite series? So remember, this is definition. What is finite series? Finite series, you say that is a summation. It's a summation of set of ordered numbers, with limited number of terms. Limited number of terms. So it's a summation of set of ordered numbers with limited number of terms. Examples. First example of finite series is 1 plus 2 plus 3 plus 4 plus dash 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 plus 10. The second example of finite series is 2 plus 3 plus 5 plus 7 plus 11 plus dash dash plus 7. So this is a series of odd numbers. Then the third example is 1 plus a half plus 1 over 4 plus 1 over 8 plus 1 over 16 plus dash 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 plus 1 over 128. So it means that a sequence can be changed into series, and series can be changed into sequence. Remember that. The second type of series is called the infinite series. Finite series. Have this question, so this will be question 1. Question 6. What is infinite series? We covered these contents into also when we've been teaching you about basic mathematics, but let us do the quick review for you in order for you to remember. So infinite series, simply that is the summation of set of what? Of orderly numbers without limited number of terms. Not limited number of terms. So examples of infinite series. So you can make these three examples in infinite series. How? 1 plus 2 plus 3 plus 4 plus 5 plus dash 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 dash. Second example, we can have also 2 plus 3 plus 5 plus 7 plus 11 plus dash 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 plus infinite. Sometimes you can find like that. Then the third example, we have what? 1 plus a half plus 1 over 4 plus 1 over 8 plus 1 over 16 plus dash dash dash. So these are three examples of infinite series. So remember that sequence is not series. Sequence is not series. Why? The terms we call these terms first term, second term, third term, fourth term, fifth term. The terms of sequence are separated by comma, while the terms of series are separated by addition. Addition can be addition or subtraction, or multiplication, and what? And division. Addition, subtraction, multiplication, and what? And division. So this is the point that you have to note. So this is example. I forgot that in previous session, that session 3, we ended in which number of example. So let me call example A, replace A with the number of examples, just to review it or check in the exercise book. So the question said that state with reasons whether the followings are a sequence or series. Sequence or series. Finite or infinite. Finite or infinite. Finite or infinite. Finite or infinite. So be given what? So refer the book called Best Applied Mathematics for Advanced Level Secondary School Students books for 5 and 6. Roman 1, 4, Roman 9, 16, dash, dash, dash. Then Roman 2, it's 1 plus 2 plus 3 plus 4 plus 5 plus dash, dash plus 9. 1, 3, 5, 7, 9, 21, 23, 4, 2 plus 4 plus 6 plus 8 plus dash, dash, dash. So this will be quiz, because we'll be giving you quizzes and homeworks. We like to teach you the method that we call active learning, which is a famous way of learning mathematics, engineering, and science or computer science worldwide, where you are the students, you have to be a center of learning process. So right now you can pause the video and then try to answer this question, which is example A. A, it's a number that if you refer session 3, and then you pause the video, you try yourself, and then you come and check the solution. That will be the active learning, right? In case that you are not confident enough, you can take advantage to go through this first example, and then in second example, you may pause the video and try to solve the questions yourself on the rough paper. Then you come and check the right solution, right? So solution. Solution. State with reasons whether the following are sequence or series. So how do you state? Roman 1. So Roman 1, first of all, this is A, Roman 1. It is a sequence. What is a sequence? Sequence is a set of ordered number which follow a certain rule, and consecutive terms are separated by comma. So these are separated by comma. So this is what? So this is sequence, because the reason is because it's consecutive. Its consecutive terms are separated by comma. Then we go A and 2. With commas, plural. Roman 2. What is series? Series is a summation of the set of numbers that follow a certain rule, right? So it's a summation. So when you say summation, it can be the summation of subtractions or difference of the terms, or it can be just the summation of the terms, difference of the terms, multiplication of the terms, divisions of the terms. So for this case, just we use addition. So it means that this one, it is series, and the reason because it's pattern. So because it is arranged at the patterns, it is arranged as what? As pattern of numbers. As patterns of what? Of numbers with summation sign. As patterns of numbers with summation sign. Then we go for A, Roman 3. Yes, this is sequence. So it is what? It is sequence. Why? Because it is arranged. It is arranged as what? So it's arranged as what? As pattern as pattern of 40, as pattern with commas. With commas. Number 4, quiz try. So once you've tried, so 8 over 4, it's what? It's a series. It is series because it is terms are separated by summation. So B Roman 1. Is this finite or infinite? It is sequence. Is it finite or infinite? It is what? It's finite. It is infinite sequence. It is infinite sequence. So it's infinite sequence because it does not have the last term. Zero. It is finite series. So this is finite series because there's a last term of 9. because it has last term of man. B Roman 3. Is this a sequence or series? It's a sequence. So is it a finite or infinite? It's finite. It is finite sequence for it has a limited number, which for this case is what? Straight line. And B Roman 4. Is this a sequence or series? It is series. Is it finite or infinite? It is infinite because there's no limited number. It is infinite series. Because it does not have limited number. Okay, so that is all about introduction. So for the introduction of sequence and series, and this is a very interesting example, which is example A. I believe that you're enjoying the truth of basic applied mathematics. Right now, ladies and gentlemen, let me teach you the concept that we call in basic applied mathematics as what? And also in mathematics, general term. General term. In order for us to learn about finite and infinite series, we have to know the meaning of general term. Remember that we taught you these consecutive numbers 1, 2, 3, 4, 5 to 9, we call them terms. But we have a terms, a special terms, which is called the general term. So general term is a common rule which describes the terms in a sequence or series. So this is the definitions of the general terms. Before you define terms, okay, yeah, let us go to the general terms. So I say that what is general term? So we say that general term is a common rule, is a common rule which describes a sequence or a series. So general terms. So general terms, it's a common rule. So we want to establish a common rule which describes a sequence or a series. So you say that the terms of sequence or series are represented, or we call it, are expressed in terms of its position, are expressed in in terms of what? Position. Expressed in terms of what? Of position. For example, if I be given a sequence of 1 plus 2 plus 3 plus 4 plus 5 plus dash dash plus 9, then we say that the first term is equal to 1. The second term is equal to 2. The third term is equal to 3. The fourth term is equal to 4. The fifth term is equal to 5. Then the last term is equal to 9. So first term, second term, third term, fourth term, fifth term, then sixth term, seventh term, eighth term, ninth term. But this is the last term for the finite series. So how do we find the general term or the last term? Okay, how do we find the general term or the last term? So there are different ways of finding general term. To obtain the general term of a series, then we have to identify what? The common rule of the sequence of the series. Of the sequence. Okay, so you have to know the terms of the sequence. Let the general term to be T of R. T of R, where R, the any position R, so R as 10. Where R is position of what? Position of terms. where R is the position positions of terms. So let the general term to be TR, where R is the position of the terms. So, for example, if you have 1 plus 2 plus 3 plus 4 plus dash dash dash, whatever the case, plus what? Plus R. Or plus, let's say, 6. Plus what? Plus, so 5, 6, 7, 8, plus 8. So we say that TR for this case will be equal to R. It means the first thing is when R is equal to 1. Second term when R is equal to 2. Third term when R is equal to 3. Fourth term when R is equal to 4. Second pattern, for example, if you have 2 plus 4 plus 6 plus dash dash, then the nth term for this case, each term is multiple of 2. So for example, this one is arithmetic progressions, however, I didn't teach you yet. So for arithmetic progressions, how do we find the nth term? So remember that this is equal to an for what? For arithmetic progression. So the nth term, if you do remember, is equal to the first term plus what? N minus 1 times common difference t. So the first term for this sequence is what? Is 2. The last term is what? Is n, so to the infinite. Then the common difference is equal to what? 4 minus 2, 6 minus 4, the common difference is 2. So the nth term, an, which in other books we call it TR, this is equal to what? First term, it is 2, then n minus 1, then times common difference, which is 2. So this will make 2. 2 times n is 2n minus 2. So it means that the nth term, which is TR, is equal to an. This will be equal to 2n. So it depends to the certain condition that sequence or series obeys. Right? So the concept, you have to remember that there is a way, or we have to know how we can find general term, or we call it nth term. General term, or we call it nth term. So it depends on the series, the pattern of the arrangement of the terms of the series. So it means that every sequence, so remember that every series has what? Has general term. General term or nth term. That's the concept that you have to remember. And finding the nth term is very important, because now we can write, instead of writing a long series, we can use the nth term and the sigma notation to write any series in a shorthand. Do you want to learn how? Is it possible? If that's the case, let me teach you about the sigma notation. Sigma notation. So the fundamental question: what is sigma notation? What is sigma notation? Sigma notation, we say that is a Greek letter is a Greek letter. So it's a Greek letter. So this is the Greek letter. Sigma notation is a Greek letter which represents summation, of terms. Of terms of what? Of a series of numbers. Series of numbers, which represent the summation of the terms for a series of what? Summation of the terms for a series of numbers. For summation of the terms for a series of what? Of numbers. So sigma notation, it is denoted as this. So this is the sigma notation. So this sigma notation, if you want to present the series, here we used to have initial value of the series, and here we used to have last value of the series, and here we used to have general or end step. So this is very important expression for the rest of your life in basic applied mathematics. So the sigma notation can present the general terms or the end stem with its initial value and last value. Whether it is finite or infinite series, the sigma notations can do great job to write any series of numbers in a short time. So if you join me right now, you're warmly welcome. I'm teaching you the beauty of basic applied mathematics for the Form 5, for the pre-Form 5 students. So you're warmly welcome to enjoy the beauty of finite and infinite sequence. So, okay, so if this is the case, so I say that simple examples, so I say that, so it means a series can be written in a shorthand as I say. This is initial value. Here we have the last value. Here you have what? Nth value. No, nth stem. You have nth stem. And in other words, the series is equal to that what? That R represents what? Represents position of terms. So we say that, for example, this is from R is equal to 1, a certain value of R, and then here we can have what? R is not a common difference, remember, because you're not dealing with arithmetic and geometric progression. You have TR. So this is the way that we can present a series. So, for example, a finite series can present in sigma notation as what? As R is equal to 1, and then maybe to 6. And here we have what? TR. While in finite series, we can present in sigma notation as what? Sigma notation from R is equal to 1 to infinite, and then TR. So the difference is the last what? The last term. So if you'll be able to express any series in sigma notation, then you are in a good, means that you are in a right comprehension of finite and infinite series. Properties of what? And then I will teach you another example, properties of sigma notation. Properties of sigma notation. Sigma notation, as a Greek letter, has the following properties. Has the following 3 properties. The first one, we call it summation of from R is equal to 1 to R is equal to n of a constant number C. This is equal to n. So this is n. It means that instant. So this it means it's the constant number. It's not a formula. So it means that the last term is a constant number. So this is equal to n times what? Times this constant number, which is C. What does it mean? For example, if you've been given to find, or maybe to write in a long term, R is equal to 1 to 20, and then the number here, the nth term, is not the algebraic formula, but it's a certain number that, let's say, 11. So this is equal to 11 times 12. The second property, we say that if you are finding summation of the series from R is equal to 1 to n. These are the rules for finite. And then here we have what? We have C, let's say C, T, R. So this is equal to C, it's constant number, where C is constant. So this is equal to what? C is constant, so we can take it out of the sigma notation. So here R is equal to 1 to n, and then here we have the nth term, which is dr. So that's the second property, and the way that we can find the desired series. That's the second property. So the third property is, if you have sigma notation of the nth term, which is sum from R is equal to 1 to this one, here we have A, TR, plus or minus B, where A and B are constant, TR, This is equal to A plus or minus AB because these are the constant. This is equal to A summation from R is equal to 1 to N of TR okay. So these are the three properties that we are going to use them consistently when we'll be dealing with sigma notation of what? Of series. So before I end this session, let me teach next example, which I will call it example B, but for you who is still remembering the number of the examples in session what? In session 3, so you have to replace letter B with what? With the number of example. So the question express the following series by using sigma notation. By using sigma notation. H1 square plus 2 square plus 3 square plus dash dash plus 20 square. B 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus dash dash. How many types of series do we have? 2. We have 2 types of series. Solution. Then I'll leave a homework for you. So we say that so these are squares. So solution for example B Roman A, we say that 1 square plus 2 square plus 3 square plus dash 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 plus 20 square. Square it is common. Right? Square it is common. So we say that the first term is equal to 1 square, whereby R is equal to 1. And you say that last term is equal to what? 20 square, where we say that R is equal to 20. Then by using this sequence, because this is finite sequence, finite series, by reading the rule or the common rule that has been used there, that this series, this finite series involves what? Involves, so do this one as your homework. So this finite series involves what? This finite series involves squares of natural numbers. So last term or general term of that series is what? Is, let's say, general term is, we say that m squared. So we have been asked to write what? Okay. So do example B, Roman B, write this series in what? In sigma notation. So ladies and gentlemen, this is the end of session 4 of Introductions of Finite and Infinite series. I ask you to join me in session 5 when I will be teaching you how you can solve different questions about finite and infinite series on the aspect of the general term and sigma notation. So invite some other friends. Remember to subscribe into our YouTube channel And also remember that to visit this channel every day so that you can take advantage of the contents that you are providing online. Again, don't forget to visit our Tanzania online advanced library, where you can access a book like this one that called the Basic Applied Mathematics for Advanced Level Secondary School Students books. And also you can access the syllabus that called Basic Applied Mathematics syllabus for advanced secondary education from 5 through from 6. This syllabus is only costing 15,000, and then this fantastic book also it's costing 25,000. So this costs 25,000. This costs 15,000. But also you have a review called Basic Applied Mathematics Review. Basic Mathematics Review. This will cost you only 17,000. So you can order a package. This is the syllabus I recommend to every student. This is the reference interesting book that I'm using, and this is the questions and answer book. So you can order this package of the books. Just send an SMS through our telephone number 0759745331. Keep enjoying the beauty of basic mathematics. This is Olenjolai from Tanzania. Enjoy basic applied mathematics for the rest of your life.